to the edge. Okay, there we go. We've got 15 people now, so I will start anyway. Right, so today we're doing exercise 1D. And I do remind you, if you haven't read your emails, I'm going, and there's going to be an online test through Cambridge for chapter 10. I will give you one for chapter 11 as well. So be aware of that and make sure that's why I need you to sign up. And we are starting exercise 1D today. We're not doing 1A, B, and C. You've already done those in the holiday homework, so we're only doing 1D. It's only a single period, so that's all I intend to do. All right, so let's start. Sums and products of functions. So we can add functions, we can multiply functions. I'll even go to say we can subtract functions and divide them, but let's just worry about these two at the moment. Okay, so if we've got two functions and we want to add them together, then we might as well just add them separately because that's what we're really doing. Okay, and the product of two functions, really, we're just going to times them together. That's all we're going to do. The domain, if we're adding them and multiplying, it is going to be the intersection of the two domains. Okay, so the intersection of the two domains. That's very, very important. Okay, example 1, f of x. We've got f of x equal to that. No one's texting me saying they can't get in. And there's our domain. X has to be greater than or equal to 2. And we know that because this is a square root. And if we put anything smaller than 2 in here, it's going to be a negative number and we can't square root it. Here, we've got g of x equal to that. And again, x is going to be less than or equal to 4 because anything bigger than the 4 is going to give us a negative under here. So add in the two functions. Pretty easy. We're just going to get f of x and we're going to add the g of x. F of x equals the square root of x minus 2. G of x is that. We cannot simplify those. So we leave it as it is. Any questions up to there? Okay. The domain. Okay, well, let's look at this domain. This domain here for f of x was x is greater than equal to 2. I don't know why I've got that. And for g of x, the domain is x being less than and equal to 4. And I showed you how to work it out, but you didn't have to do it like that. I'll put the equal sign in here. I've got my square brackets, but I don't know why I didn't put it in there. So just add that in, please. So the domain of f plus g equals between 2 and 4. Remember the intersection and the intersection. So if we've got x equals 2, and if we're looking at all of those ones, and then we've got x equals 4, and we're looking at all of those ones, then that's the intersection between them. Any questions on part A? Part B in green. Here we're doing f plus g of 3, where we've already worked out what f plus g of x is. So all we're going to do is in here, put in the number 3. So we get the square root of 3 minus 2 plus the square root of 4 minus 3. 3 minus 2 is 1, square root of 1 is 1, 4 minus 3 is 1, square root of 1 is 1. So we get an answer of 2. Any questions on that one? Okay, part C. Here we are multiplying. So we're multiplying f and g. So again, I'm just going to get my f, which is the square root of x minus 2. I'm going to get my g, which is square root of 4 minus x, and I'm going to times them together. And we can simplify that. We can put them under one square root. I wouldn't go so far. You can expand it. I don't expand. There's no need to expand because this is in factorized form. If you expand it, then you're not going to have any factorized form. So just keep it in factorized form. Then we substitute for part D, f, g of 3. So we're going to substitute 3 in there. So we get 3 minus 2 and 4 minus 3. Again, when we work that out, we're just going to get the square root of 1, which is 1. Questions? Okay. I'm going to clear this and I'll move it up. Now, addition of ordinates, that's going to be a little bit hard to show you, but let's just bear with me and I'll try my best. Now, what does addition of ordinates mean? It means we're sketching one graph, sketching the other graph, and then we're going to, if they're above the x-axis, add them together. If they're below, they're a minus. So if we've got a point up here and a point up here, then this distance here, we have to take away from this distance, so the new graph comes there. Okay, that's what addition of ordinates mean. So let's have a look at this one here. Then we'll go through the table as well so you can see. Here we've got a straight line, f of x equals x plus 1. So when we put x, all these x values into f of x, we get these answers. When we put these same values into g of x, we get these answers, and we can sketch our graphs. There's my f of x, there's my g of x, the blue one. Okay, the dark red one is them added together. So if I add the 0 plus 5, I get my 5. If I add the 1 plus 3, I get my 4. Add these two together, you get the 5 and 2. Add these two together, and you get your 2. So we've got our answers. But let's say we don't have the table. They just give us graphs and there's no numbers on there. How do we do it? Because then we can sketch this, not a problem. So let me just clear all this on the table in particular. Okay, so this blue one crosses at the 3, and the red one, when x equals 0, crosses at the 1. So because they're both above the x-axis, this 1 I'm going to add to the 3, and so I get a pointer there at 4. Does everyone agree with that one? Okay, another one that I'm going to do here, it's 0. Okay, there is no point, it's on the x-axis, so it's 0. So I can add it to this dotted line. So 0 plus wherever this dotted line is still going to be there, so that's why that one crosses right there. And we're getting the graph looking like this so far. Don't have to do every point, because remember, they're straight lines. Straight line plus a straight line is only going to be a straight line. But any questions there? Okay, we will do this point over here, so I'm going to change my color. Hopefully purple works nicely. Yep. Okay, this point over here, I know I can see it. Right? It's that far distance. Even if I don't have numbers, remember, you can just measure it. Use your pencil or your pen and you just measure it. So that distance I'm going to take away, because underneath the x-axis minus, I'm going to take away from this dotted line, because that's my line of y equals f of x. So that distance is about that much that I'm taking away. So that's why that dot's there. Okay, any questions how we do addition of ordinates on a graph? If it's in a table format, it's pretty easy. Okay, I'll let you take some notes down, whatever notes you guys are taking. I'm pretty sure there's another example with this. Okay, I'll clear it. Okay, example 2. It says sketch the graph of y equals f plus g of x, where f of x equals the square root of x. G of x equals x. The function with the rule f plus g of x equals the square root of x plus x. We know that because if we add them together, we're going to get the square root of x plus x. Okay, but let's now do it by addition of ordinates. So we all know how the square root of x looks like. Okay, it starts at the 0 and it's a curve like that. And we can see it there, that's the dotted blue line. We also know this is just a straight line, y equals x. Just because we call it g of x, that's because in function notation. That's just a straight line, y equals x, goes through the origin. So they both start at the origin. Not a problem, we can see it there, it's the dotted red line. But we have to add these together to get this rule. Okay, so here we know that when x equals 1, the square root of 1, 1, and this one here will equal 1 as well. So they both cross at the point 1, 1. So that means it's doubled. When x equals 1 for the new graph, it's going to be at y equal to 2. Now, we can make up some points, but we don't have to. We know that we have to add this much, this distance, 1 on to this. So it's roughly about that much. It's not going to be 100% because we don't know what that number is. That's how we do it. We have to add this distance onto the red line because they're all above the x-axis, so it's about that much. We have to add this distance from here onto this red line, so we can get our curve happening, which is a dark red line, the solid red line. Any questions on that one? Okay, I'll clear this one. Example 3. So sketch the graph of y equals f minus g of x, where f of x equals x squared and g of x equals the square root of x. Well, again, we're just going to sketch those and then we will subtract them, okay, because that's what it means. Okay, so remember, when you subtract them, you are subtracting the negative numbers. Okay, so be careful with that. So x squared, we know x squared is just a parabola, not a problem. There it is there. Did they give us any rule? Well, we'll better find our rule, but we can see it. There's our blue one. Okay, I'm just going to extend that one. So that's our x squared. We don't need the negative part because g of x, which equals the square root of x, just looks like this. Okay, but we want to subtract. So when we sketch this one, and we're subtracting this g, so when we sketch this one, instead of sketching it like that, we can sketch it underneath. Okay, so that is the g of x negative the square root of x. This one here is the g of x, which is positive the square root of x. Any questions there? And because I've sketched the negative, all I really am going to do is add them together. But you could have done it the other way. It's not an issue. You could have subtracted it. This part, as I said, is not required because the square root of x graph does not exist when x is negative. So you can sketch it, but you're not going to do anything with it. Okay, so we've got our two graphs. We've got our y equals negative g of x, and we've got our y equals f of x. And we're going to do now, because we did the negative, we're just going to add these distances again. So I'm just going to change to green. So there's that distance there. I'm going to subtract because it's underneath the x-axis. There's that distance there. I'm going to subtract. They both are, all of them are at 0, 0. So really, we've got a graph, or this one here. The blue one, we're going to take away from the yellow one. So the yellow one's going to come in a bit. This blue one, we're going to take away from the yellow one. So it's going to come in a bit. This part here, you've got to see which one's got more distance, right? So this part here, compared to this part here, from there to there, I'm going to change color from there to there. Well, the green one's shorter, so I'm going to take the green one away from this purple one. And therefore, when I take it away, the dot comes there. Okay, so you've got to see which distance has more from the x-axis. Okay, so here, the blue one was more, we remove the green one. Here, this blue one is less, so we've got to remove it from that one. Any questions how I did that? Okay, now that you've drawn the graph, I mean, you can work out the domain by seeing where these two intersect, or you can even see it from the graph. You can see that it starts at 0 and it continues to infinity, this dark red one here. Okay, it continues to infinity, so you can just write your domain. You don't have to work it out there, you know, by finding the intersection. But if you want to see the intersection, this part here was all reals. This is reals positive. Okay, so the intersection between these two is only real is positive, including the 0. So that's why we get 0 to infinity. Any questions on that one? Okay, I'm only doing one exercise. I want to make sure that you guys know how to do this part here. Let me just clear this and get out and stop the sharing. Okay. Does anyone have any questions that they would like to ask me before I do that question 13? Because I did get that question 13. I can't remember who asked me from that chapter 11 review. I don't know what I did yesterday, but I did get it. Where's my share? There we go. Whiteboard. So have you got any questions?
Just for that exercise that we just did, so is that just like eyeballing it?
It is basically, yeah, because you don't have numbers along the y-axis, it's just eyeballing it. Now you can put points in there yourself. You can put, because you've got the rules, the two rules, you can put x equals 1, x equals 2, x equals 3, etc. Right, as many points as you want, substitute them into each of the functions, add them together, and you got your other point. Okay, just like in the first one, in the first example where we had on the side the table, where we did f of x, g of x, and added the points to get f plus g of x.
Alrighty.
Okay, so you can do it like that. And some ones where they just give you the graphs and you don't know the functions, you have to eyeball it, exactly what you said. Have I seen anything like this on the exam? Never. Okay, I've never seen it. It leads into something else when they talk about restrictions, and we have to restrict a function to make it happen. That's what it's all leading to. Okay.
Cool beans.
All right. If you've got any questions, please keep emailing me. I'm just going to move this a little bit out the way. I'm going to do that question 13. It is quite long. Okay, so I'll do 13A first. I've still got it open. Okay. I won't draw the picture, but if you guys can have the book opened, it's page 529, then you can see what I'm talking about when I'm talking about things. And I had to do the whole question because I can't concentrate without the question. So this is chapter 11 review, question 13 from the short answer. Okay, and part A says to find the points A and B. And I know, I can't remember who told me to do the question. You gave me the question, but I still had to do this for me, for my own personal thing. So point A, of course, we're finding the y-intercept, so I'll put x equal to 0. Okay, so I had 0 on the function, 6y minus y squared. Of course, I factorised, so I've got y, 6 minus y equals 0, so y equals 0 and y equals 6. So the point A was 0 and 6. And then I did the point B, and that's where the two rules are equal. So I made them equal. So I got y squared minus 5y equals 0. So y minus 5 equals 0. So y equals 0 and y equals 5. So point B was 5 and 5 because we can see the x value. No, we know that the rule is y equals x. So x is equal to whatever we had for y. So that's part A. Then part B, find the area of region P. So we have to find area of P. Okay. Now, area of P, we can see, we're going to turn the graph the other way because normally, and I'm going to write this down on the side, but this is nothing to do with this question. Okay, normally when we have our axes and we draw our graph, and I'll just draw an upside down parabola, we're finding the area, say, in there, it's between x equals 0 and whatever that point is. This graph, if you look at it, goes like this along the y-axis. So we're going to change our axis and we're going to make our y-axis the same. So really, P is in there. So we're going to find the area from the 0 to this number here, which is the intersection of B, which is the y equals to 5, and then from 5 to 6. So we get two areas that we're finding. We're finding this part in here first, and then we're finding this part in here second. And we're going to add them together. Does that make sense to people?
Yeah.
Okay, so we're going to do for the area P, we're going to do the area from 0 to 5 of that straight line, which is x dx. Oh no, it's y. We've got to do it in terms of y. Let me get rid of that. Not x, y. Just so used to writing x. Y, dy, plus the integral from 5 to 6 of the other one, which is 6y minus y squared. Okay. Do you want me to do all the integration, or can I just go and leave a couple of steps? You know what, I'll just do it. Y squared divided by 2 between 0 and 5. 3y squared, that will give me the 6 minus y cubed over 3 between 5 and 6. Okay, substitute the 5 in. 5 squared is 25. 25 on 2 minus 0. That's the first one. Plus the second one, substituting the 6 in. 6 squared is 36. 36 times 3 is 108. Minus 6 cubed divided by 3 gives me 72. I don't know these answers off the top of my head. I've actually worked them all out. Okay, so minus, putting the 5 in. 5 squared is 25 times 3, 75. Minus 5 cubed divided by 3 is 125 divided by 3. Okay. Gives me 25 on 2. Actually, right now I can write the answer because you guys should be able to work the rest of it out from there. So when we do simplify this, we end up getting 91 on 6, which is the 15 and 1/6. And because it's an area, make sure you have your units of units squared. If it was metres, we put metres squared. Okay, is that enough work, or do you want me to really do the whole thing from there?
That's enough.
That's enough. Nicole, I did read your little chat. What questions I will put up on Google Classroom or email you, one of the two, or probably both, which questions to do. So just bear with me for a minute. Part C, I'll try and squeeze part C in here. Part C is fine in the region of Q, which is, of course, where's my colour? I'll use brown. Q is that part there. Okay, so let me just change back. To do Q, we're going to work out the whole curve, right, that graph there, right, from 0 to 6 of the 6y minus the y squared, and all we're going to do is subtract our P, the area of P, which is all, change my colour again, all that section there. Because if we're working out all the area under the graph and subtracting this one, that will give us our Q part. So that's what we're going to do there. Again, when we do this, we already know this answer. The integral, I've already worked it out at the top. Oops. 3, no, it is 3y squared minus y cubed over 3 between 0 and 6 minus our answer for P. I'm going to leave it as 91 on 6. That's a 6. Putting in the 6 in there, we already had our answer. It was 108. There it is there, minus 72, which gives us 36. So this becomes 36 minus 91 over 6. And we work all that one out. It's 125 over 6 units squared. So we can use the information that we've already done in part B. Don't work all this out again. Okay, you've already got that answer. Oh no, that's wrong. Oh no, but it's right, because the 6, that's the 6 part there. Okay, when we substitute x equals 6, that's when we substitute the 5 in there. So we've already got the answer there. Don't redo the whole thing. Okay, that's the only question that I had to do with you guys. No one sent me any more. So unless you guys have questions now, then I'll try and get them done. If not, just email me and I can tell you which questions you're doing for chapter 1. I thought I had a list. Okay, let me go back, chapter checklists. Chapter 1, where they are. Okay, so for 1D, I'll just read them out to you right now. It's question 1A and D. Question 3. Question 5. Question 8A. Question 11. And question 12B. Of course, you can do a few more, that won't be an issue. And I will put this up on Google Classroom as well.
Okay. I've got a question.
Yep.
For the first part in A at the end, how do you get both sides 5 for the coordinates?
Sorry, for part A?
For the first part, yeah.
This question here?
Both 5s.
Well,
Yes.
when y equals 5, we substitute into this one here, into the rule y equals x. So if y is 5, then x is 5.
Okay.
Okay, because that's one of the rules. Y equals x, and the other rule is x equals 6y minus y squared, and they both intercept there, so they're both equal. So you can use either one. So we might as well substitute it into here. And if that's 5, then x equals 5 as well.
Okay.
All right. Any other questions?
Sir,
Yep.
where's the chapter 1 notes though? Did you send them to us?
Yeah, I put them up on the Google Classroom. All chapters, all
Oh,
this term, all these term ones. Yep.
Okay, thank you.
Okay. All right, guys. Just you're going to receive another email from me. One I've already sent yesterday. If you give me permission to put these videos to the other staff, and some of you have responded, thank you very much, and also to put it on YouTube. So thank you to everyone that's responded. Now you're going to be getting the invitations to Zoom, and hopefully I do make them as